Pretty much. It's hard. It's hard to hear that. Okay, so what you need to do is, what is the base on any of these laws? 10. They're not stated, so they're 10. They're our standard law. Right? You all know that? So what would you do in your calculator? Log 6 plus log 5. Go away. Did you? Okay, you guys are really ruining it. You're not being comfortable because there's no log 30 in that line. You're correct. Okay, so I'm going to go log 5, close that bracket, plus log 6, close that bracket, and enter. So I'm going to get 1.4, we'll just go 3 decimal places, 1.477. Okay, so since you guys are big ruiners of my fun, let's skip right to log 30. So if we put log 30 in the calculator, something like that. Big ruiners. Big ruiners. So what would you anticipate log 99 and log 11 plus log 9? Would you anticipate those to be the same? Yeah. Okay, so there's your first log. Nothing's done, you can go home. You're probably pretty much ready to write the exam. So what you've just done is the product log law. So if they have, but this is the key thing, it's like your exponent law that you learned in grade 9, they have to have the same base. You can't apply any log laws to different base laws. That makes sense to everybody? Like, I can't apply, like, I have 3 squared times 3 to the exponent 3, I know my answer is going to be 3 to the exponent 5, right? We know that. I cannot do it if it's this. I cannot say the answer is going to be 6 to the exponent 5. I can't do that. So no log law, no exponent law you can apply here. Same thing with logs, they have to have the same base. So the log of the product. The log of the product of 2 factors is equal to the, what am I doing here? The sum. Okay, so knowing what you know about exponential laws and knowing what you know about product, the sum log law, what do you anticipate? What? Sum. Which ones do you think will match, ladies and gentlemen? What do you think you're doing here with these? You're dividing now. So which ones are going to match? So this one, I'll go 1 and 3, but it's okay. Roman numerals are tricky. I and triple I. And then this one and this one would match. Okay, so let's do this in our calculator. So log of 12. We'll go 3 decimal places, so 1.079. And so we said the one that we think matches is going to be 48 and 4. So if I check that one, so log of 48, close brackets, minus log of 4, close brackets, same thing. I might cry a little. So this one, if you did it in the calculator, is 1.556, and this one is also 1.566. 556, yeah, sorry. I just gave up. Nobody's listening to me anyway, so. But you make a mistake, you make one mistake, and then, you know, you make a trouble for the kids. You went to grade stuff, like, that's probably the worst. Like, it's one thing you're just, yeah, but it's a total other thing that you say, I skipped 4 math class to go to another math class. That is a good analogy. So what do you think goes in this line? What do you think goes in this line? Subtract or difference? Difference. So the arguments, if the logs have the same base and they're subtracted, you can simply divide the arguments. So when we're going to division, it matters about the order. Multiplication doesn't really matter so much about the order, but division it does. Because you're going to get a very different answer if you take 4 divided by 48 as opposed to 48 divided by 4. So order matters there. So please make sure you pay attention to that. Woo, look at all those questions. We did one of these before, I think. So this one and this one match. I'm ruining the fun. Oh, it's the exponential rule. So this one really could be written as, so we don't want exponents inside logs. It's kind of like having decimals inside fractions. It works, but it's not mathematically or grammatically proper. So what we do in logarithms, if your argument has an exponent, that exponent gets moved out to the front. Or you can actually evaluate it, which in this case we went to log 49. So if I do that in my calculator, if I do log 49, I get 1.690. And if I do 2 log 7 in my calculator, I get the exact same thing. All right, so this is the power here. So I don't want anybody to be writing their logarithms with exponents, their arguments with exponents. You will get a half-mark deduction. Ooh, that's a good question. Ooh, that would be a full mark for concept error. For sure. Usually I do that anyway, but you can all. Is that for you? All right. So the log of a factor to a given power is equal to the power what? What are we doing? The power, what does the power do? Is it to the exponent? Is it multiplied? Is it divided? What are you doing with that power? What operation is here between 2 and the log? What's happening between 2 and log? You're not exponing it, you're multiplying it. You're not exponentiating it. You would be putting the exponent on the 7th and evaluating that power, but when you put it in correct form, really you're taking 2 and multiplying it by log 7. Okay. Does that make sense? I think what I'm interpreting what you're saying is you do this. And that's wrong. If I did that in my calculator, no. You're evaluating just the argument, not the entire law. So here, you would write it like this. Does that make sense? This is not equivalent to that. These are two totally different things. Okay, so this one is multiply. So if you have an exponent on the logarithm, it gets moved out front. I feel like maybe I have 4 people's attention, and then everybody else is doing something else. Do you mind? Because this is, you told me, this is where you need to pay more attention. Perfect. Okay. So the benefit of using log laws is that you evaluate less. If I were to ask you to do this, you'd have to evaluate this log, and then evaluate that log, and then add them together. By doing log laws, you simplify it first, and then you only evaluate once. That's the purpose of log laws. So if we were to do this, how would we rate this as a single log? Woo. Okay, now we need to evaluate it. Now we need to evaluate it. What do we do? Exponential form. So what is it? 2 to the exponent some variable k is equal to 32. So for us mere mortals who need the extra step, this would be 2 to the exponent k. I have to figure out 32 as a base 2 number, which is 2 to the exponent 5. And then once you have the same basis, you do not divide them out. I can't tell you that enough. You do not divide them out. You just simply drop them. You lose them. If you divide them out, that's a full mark concept error. Happens all the time. Please don't be those kids. Don't say sorry. You're just not going to do it. Okay, this one's a little bit more complicated. So we have subtraction, and we have a power. It might be easier to do this. Log base 2 x to the exponent 4 minus log base 2 x minus 1 plus log base 2 x squared plus 1. Yep. You're not going to be able to evaluate this because you'll end up with 2 variables and you can't do that. So we're going to simplify it. So what happens? So they all have the same base. So it's log base 2. So this, and this are all the same. I can go ahead and use my log law. If I am subtracting them, what am I doing? Dividing. So I'm going to have x to the exponent 4 on top, x minus 1 on the bottom, and then I'm adding this log in. So what am I going to do? Multiply. Now, if we're going to put that into exponential form, it's going to be a little bit ugly because you have 2 to the exponent k equals x to the exponent 4, x squared plus 1 over x minus 1. That isn't even a difference of squares. I can't cancel anything out. I have a k and I have lots of x's, so I can't evaluate this one because I have 2 variables. Does that make sense to everybody? We would leave it at this point. Well, we leave it at this point because we'd simplify the log in this, but I'm missing one thing. Get back to chapter 9. NPVs. As soon as you have a variable in that denominator, always you have to put an NPV in. I don't care what chapter you're in, this is your life now. So what's my NPV? Cannot equal 1. Okay. Do our best. Okay. We're going to expand it. So you're given the simplified log. Now we're going to expand it. Not hard. Not hard. So how many terms am I going to have in my expansion? 3. Root x, y squared, and x. I'm going to have 3 different ones. Was that a guess? The great guess. Oh, well, look at that. We'll just go and give you exactly what you were talking about. So what's happening between these two? They're being multiplied. Your numerator's being multiplied. So based on our log laws, what are we doing? We're adding them. So I'm going to have log base 3 root x plus log base 3 y squared. And now this is divided by x. So what am I doing? Minusing. So I have minus log base 3 x. Don't forget the base 3. Half-mark deduction. Okay, so what do we do now? Because this isn't finished. Okay, so this changes into an exponent. So log base 3 x to the exponent 1/2 plus log base 3 y squared minus log base 3 x. Okay. Oh, that should not be up there. Oof. There we go. So now what? Put them in the front, put the exponents in the front. So half log base 3x plus 2 log base 3y minus log base 3x. I can combine like logs. Just so, like I said in math, our math rules are consistent and they're true throughout things. So the same rules you apply to algebra, you're going to apply to your logs. So because this is log base 3x and this is log base 3x, these are exactly the same log. I can combine them just like as if they were 2x squared plus 4x. I can combine those. So I have a half log base 3x, and I have a negative 1 log base 3x. Negative half. Can I combine this one in? How come? They're not the same. Anybody know why I chose to write it this way? Would you be wrong? No, I don't think you would be either. Do you know why I chose to write it this way? No, because I'm worried I'm going to drop that negative. People like seeing it as a subtraction sign. They're more comfortable with it than negative on the front. If you wrote it in the opposite order, you'd be perfectly fine, just as long as you don't drop that negative half. Does that make sense, everybody? You do not have to write it this way. You can write it in the other order. Okay, crying baby. What else, friends? What? I don't know where you got lost. I just finished explaining this. So you need to be more specific. Somebody explain it to us. How many terms in this one? Perfect. And it's not a log base 4, what is it? And log base 10. Okay, so here is a really good question. Ooh, that's only 3. I'm not saying it. I gotta know how to move forward. Yeah. I haven't finished yet. I want to stop. I just want to stop at the conversation. Yeah. Okay, so that's what I want to talk about, Carson. I want to talk about the use of brackets or the non-use of brackets. Both are correct. So here's the thing. Before I write my next one null, my question is, do I use brackets or don't I use brackets? I'm going to use brackets here because what's happening between these two? They're being multiplied, so that would turn into an add. Null? There's my other one. But you wouldn't be wrong if you did this. Okay. Be forewarned though that if you don't have brackets, if you didn't have brackets, this would be incorrect. Because if you said minus log y squared, that moves it to the denominator. If you say plus log x, it moves it to the numerator. If you don't have brackets, what this is saying is we're subtracting all of this. Or you could write it as, I know this is on a denominator, so I'm going to put a negative in front. This is on a denominator, and I'm going to put a negative in front. So it's how you choose to do it. It's the same thing. It's you're distributing the subtract sign throughout the bracket. Yeah, that's what we're doing. But you can just break it. Okay, so now I need to move my exponents forward. You need to make sure that you recognize roots as rational exponents. So what's my exponent going to be on that x? 1/3. Okay, so Kevin, what am I doing? So I'm going to combine this one, and that one. I don't know what you're asking. Yeah, this one? Yeah. No, because like this would be a third plus 4 is 4 and 1/3, or 13 over 3. Yeah. Right. Thanks. Minus 1. Yeah. Well, I distributed this, so you would have to go ahead and distribute it through. I'm okay if you skip this first line and jump right to this, but what I'm not okay with is you writing it like this is wrong. If you don't have those brackets on there in that first line, it would be incorrect. Because that would mean that you're adding 1 and really you're not adding 1 in that level. Okay, so this is 13, what did we say? 13 over 3. And then we're going to minus 3 over 3. So I have, I'll go to positive 10 over 3 log x minus 2 log 1. Can you make it into a decimal? Those jobs? 3 and 1/3, perfect, that's fine. Just this would be a question on your non-calculator portion. So don't change it to decimals. You're going to be, especially with something with a repeating denominator, that's going to be a pain in the butt. every provincial exam. It's a 1-mark question. It shows up on every provincial exam I've seen. You don't have to do it. You know what? Luckily, I'm here to help, and I do remember how to do it. You don't remember? We're good. Just give it over for everybody else. Matthew knows how to do it, so we're not going to do it. Okay, so this is a situation where in our calculators, I can't do base 8 numbers. Don't say anything, Kevin. Go away. I haven't got there yet. Okay. Okay. So it's given us some values, and all we know is we have factors. Base 8, we know factor could be 2, factor could be 3. So break 18 down into, do you guys remember factor trees? Grade 9, I think Ms. Deeds is the only one who does that. If you're in Steve's class, yes. Okay, well that's pretty standard because you still get that in my class, so. Okay, well there we go. Give me 2 factors of 18. 9 and 2. Okay, no, I just want 1 factor pair. Okay. Okay? Okay. Okay, 2 is a prime number. So this branch stops at prime number. Okay? Factor 9. Whew. 3 is a prime number. 3 is also a prime number. So this factor tree stops. 3 times 3 times 2 should give me 18. And the reason why I wanted to break it down into 3s and 2s is because that's the information I have. So instead of writing log base 8, 18, I'm going to write log base 8, 2 times 3 times 3. Because that's the exact same thing as 18. If you multiply 2 by 3, that gives you 6. 6 times 3 is 18. Right? Because that's the base given. That's the base given. So this is based on information that we know. So we're going to expand this. These are all multiplied together. So what am I doing with the individual logs? I'm writing them down and I'm adding them together. I love the complaining. That's probably my favorite part. So this would show up in a non-calculator portion because you don't need your calculator for any of this. It tells you what log base 8, 2 is evaluated to. And that's going to be added to, it tells you what log base 8 argument 3 is, so 0.52852. And you got another one of those. So how many of you would actually have, no? Okay, and I don't know, I'm going to add those together. That's 1.39037. You're adding. You know how to add decimals? See, we just get my class. You don't know how to add decimals. Maybe, good point. We'll get that off to this friends. Okay, another thing, I've seen this on a provincial exam where it replaces them with shapes. So it changed this to, what was it? This was a star. Let's just make it a heart because I can't draw a star. And hey, no judgment here. And this one, let's say, was a cube. So they would expect you to do the same thing, but then you would have heart plus a cube plus another cube, and your answer would be heart plus 2 cubes. So I've seen it done like this with the numbers, and I've also seen it done with pretty pictures. It was a sun and moon and stars one year. That was fun. So just be forewarned, this will show up on a provincial exam. It might show up on a test, but I've seen it every year in some format or another. In the non-calculator part, when people start freaking out because they can't answer it. I can't answer it. I have my calculator. I can't do anything with it. It gives you all the information. You just have to do your factor tree or your shape breakdown. Shape tree. This is the exact same thing. Exact same thing. So what do we have? What do we have? 2s, 3s, and 5s. So that root sign is over both of them, right? So this would be like saying log base A root 10 over root 3. Same thing as saying log base A root 5 times 2 over root 3. I don't think we need a factor 3 for 10, right? We might. Steve is the only person who does it. I've never taught it, and the only time it comes in handy is in that question with logs. Okay, so now what are we going to do? Same thing we did in that question above. So break it down for me. Log base A, root 5, plus log base A, root 2, subtract log base A, root 3. Can I leave them as roots? Can I leave them as radicals? No, so this is going to be 1/2 log A 5 plus 1/2 log base A 2 minus 1/2 log base A 3. Can I combine any of those? They're all base A's. How come? Different args. The arguments are all different, so you can't combine them. Even though they have the same basis, you can't combine them. They're all different. So can all this be one that you'd be given in a calculator section? Because this is equivalent to this. So you have 1/2 times 0.8271 plus 1/2 0.3562 minus 1/2 of 0.5646. And you would combine them all. You would combine them all and you would get 0.30935. Guys, I want to be very, very specific that notice I have no equal sign anywhere. I'm simplifying, and in this case I get to evaluate. If you put an equal sign in here at this point, that's a half-mark deduction. You got it?
I did the same thing last week.
Be very conscientious of that, the switching from expression to equation. I know it's equal to this, but we've never had an equal sign all the way through, so you gotta keep going with that as well. Put a nice circle around the ball.